Hello everybody. This is lesson 19 of the lecture Macroeconomics. I will discuss the slides 87 to 96 of chapter 4, the Keynesian model. In this lesson I will introduce the capital market where investments are financed. We will then analyze the interaction between the capital market and the market for goods. The Keynesian cross, which we have derived in the last lesson, reveals the basic features of the Keynesian theory. It suffers, however, from the shortcoming of a constant investment level. Keynes assumed that firms' investment depends on two factors: the capital market interest rate, which represents the costs of investment, and the expected return on investment, which we use the symbol E depending on the return. E represents the mathematical expectation value. So E from R represents the expected return on investment. Like the neoclassics, Keynes assumed that a higher interest rate reduces firm investment since it increases investment costs. Following Keynes, an increase of the expected return on investment increases firms' investment, since more investment projects become profitable if their return is higher. In a diagram where we register the interest rate on the y-axis and the investment credit demand on the x-axis, the investment credit demand function then displays a negative slope, like this function here, which means that the investment credit demand depends negatively on the interest rate. We have already discussed this for the neoclassical model. According to the Keynesian assumption, the investment demand of firms depends positively on the expected return on investment. As a result, if the expected return increases, the investment credit demand curve shifts to the right or upwards. So the expected return is here a shift parameter for the investment credit demand function. If, to the contrary, the expected return decreases, the investment credit demand curve shifts to the left or downward. How do we now find the position of the savings supply curve on the capital market? Because of the household budget constraint, the savings decision of households is not independent from the consumption decision. The household budget constraint equals household income, which in this case is equal to GDP, equal to consumption plus savings. Subtracting now consumption from both sides of the equation yields this equation. Placing GDP outside of the brackets shows that savings are also a function of only GDP and one minus the consumption ratio. 1 minus the consumption ratio is what we can call the savings ratio. Consequently, savings, like consumption, do not depend on the interest rate under the assumptions of the Keynesian model. So, if the equilibrium level of GDP equals 30 units, as in this goods market equilibrium here, then household savings equal 50% times 30, which is equal to 15 units. So the savings supply curve is a vertical line on the capital market, whose position depends on the equilibrium GDP level and the savings, or respectively the consumption ratio. It is now interesting to see that given this savings supply curve here, the resulting interest rate causes an investment demand of 15 units. And this investment demand now equals the investment goods demand on the market for goods. It's equal to the investment goods demand which we have assumed on the market for goods. However, this result is not by chance. It is, in fact, a mathematical necessity, which is called Walras' law. It is quite simple to derive Walras' law in an economy which consists only of a capital market and a market for goods, as the following digression shows. Walras' law was discovered by the French economist Léon Walras, and in the year 1874 published in his book Éléments d'économie politique pure. It says, if the number of all markets in an economy is equal to, let's say, n is an arbitrary number, and n minus 1 markets are in equilibrium, which means demand equals supply on n minus 1 markets, and all households keep their budget constraints, which means spend not more and not less money for consumption and savings than equals their income. Then the nth market will automatically be also in equilibrium. So this sounds perhaps a little bit abstract, but if you refer this theorem or this law on our economy with only 2 markets, it becomes quite simple to understand. In our version of the Keynesian model so far, we have only 2 markets, the goods market and the capital market. Hence, n, the number of markets, is equal to 2. Consequently, if the goods market is in equilibrium, such that GDP equals demand for consumption goods plus investment goods demand, and households keep additionally their budget constraint such that GDP equals also household consumption plus savings, then the capital market must necessarily be in equilibrium too. which means savings supply must be equal to investment demand, such that this equation here holds. So these two equations imply, in other words, necessarily that this equation here holds. I think it is quite simple to see that this is a true statement. We can also use a little bit formal calculus to prove this sentence for the case of our two-market model. If one subtracts the budget constraint, this equation, from the goods market equilibrium equation, we receive this equation here. So on the left side we have GDP minus GDP, which equals of course 0. And on the right side we have consumption demand plus investment demand minus consumption demand minus savings. So consumption demand minus consumption demand is 0, and as a result what remains is investment demand minus savings demand, which must be 0, since we have found that GDP minus GDP is 0. Now we can take savings on the other side of the equation. We add plus savings, so it disappears on the right side and reappears with a positive sign on the left side. And then we have the equation that savings must be equal to investment. This is what we wanted to prove. If this equation is true and this equation is true, then necessarily this equation here, the capital market equilibrium, must also be true. So this means we have now proven Walras' law for our two-market Keynesian model. So much for this lesson. In the next lesson we will analyze the consequences of demand-side shocks under the assumptions of the Keynesian model.